Hello everyone, welcome to our new video on the most asked Python interview questions and answers for fresher and experienced developers. Whether you're preparing for a job interview or simply looking to brush up on your Python knowledge, this video is for you. So if you are ready, let's start today's video. Question 1. What is the purpose of the yield keyword in Python? Answer. The yield keyword in Python is used in the context of generator functions. It's used to pause execution and produce a value from the generator function. When a generator function encounters a yield statement, it returns the value specified after the yield keyword and suspends its state. The function can then be resumed from where it left off when called again. Here's a basic example to illustrate the purpose of the yield keyword. In this example, count_up_2 is a generator function that yields numbers from 1 up to a specified limit. When count_up_2 is called, it returns a generator object without executing the function body. The for loop iterates over the generator object, calling the generator function each time to produce the next value. Each time the yield statement is encountered, the function pauses, and the yielded value is returned. The function's state is preserved, so it can be resumed from where it left off. In summary, the yield keyword allows you to create iterable sequences efficiently without storing all the values in memory at once, making it useful for working with large or infinite sequences. Question 2. Explain the concept of duck typing in Python. Answer. Duck typing is a concept in programming, particularly in dynamically typed languages like Python, where the type or class of an object is determined by its behavior rather than its explicit type. The term duck typing comes from the saying, if it looks like a duck, swims like a duck, and quacks like a duck, then it probably is a duck. In Python, this means that an object's suitability for a certain operation is determined by whether it supports the required methods or behaviors, rather than by its inheritance or type declaration. If an object implements the methods or attributes needed for a particular operation, it can be used in that context, regardless of its actual class or type. Here's a simple example to illustrate duck typing in Python. In this example, we have two classes, dog and duck, each with a sound method. The make_sound function takes an object as input and calls it sound method. Even though dog and duck are instances of different classes, they both work with make_sound, because they both have a sound method. This demonstrates duck typing. If it looks like a duck, implements the sound method, it's treated like a duck, can be passed to make_sound. Duck typing promotes flexibility and code reusability, as it allows objects of different classes to be used interchangeably as long as they support the required behavior. However, it also requires careful documentation and testing to ensure that objects are used appropriately in different contexts. Question 3. How can you handle circular imports in Python? Answer. Circular imports occur when two or more modules depend on each other, directly or indirectly. This can lead to errors where one module tries to import from another module that hasn't finished importing yet. Python provides several techniques to handle circular imports. 1. Restructure code. Refactor your code to remove circular dependencies if possible. This is often the best solution as it simplifies the code base and makes it easier to maintain. 2. Import inside functions or methods. Import the required module inside functions or methods rather than at the top level of the module. This delays the import until the function or method is called, potentially avoiding circular import issues. 3. Import at the end of the module. If you can't avoid importing a module at the top level, you can import it at the end of the module. This ensures that the module being imported has already been fully defined. 4. Import in the function that needs it. If circular imports occur due to class or function definitions, import the required module inside the function or method that needs it. This localizes the import and prevents it from causing circular dependencies at the module level. 5. Use importlib. Python's importlib module provides functions for dynamic importing. You can use importlib.import_module to import a module dynamically at runtime, which can help avoid circular import issues. 6. Dependency injection. Pass dependencies as arguments to functions or constructors rather than importing them directly. This decouples modules and avoids circular dependencies. 7. Forward declarations. Use forward declarations or placeholders to break circular dependencies. This involves defining a placeholder class or function in one module that is later replaced with the actual class or function from the other module. These techniques can help you manage circular imports in Python effectively. However, it's essential to consider the design and structure of your code to minimize dependencies and prevent circular imports wherever possible. Question 4. What are the different ways to handle multi-threading in Python? Answer. Python provides several ways to handle multi-threading, each with its own advantages and use cases. Here are some of the most common ways. 1. Threading module. Python's built-in threading module provides a high-level interface for creating and managing threads. You can subclass the thread class or use the thread constructor to create new threads. This module is suitable for input-output bound tasks or tasks that involve waiting for external resources. 2. Thread pool executor. The concurrent.futures module provides a high-level interface for asynchronously executing callables, functions or other Python objects, using pools of threads or processes. The thread pool executor class allows you to submit tasks to a pool of threads and manage their execution. This approach is useful for parallelizing CPU-bound tasks. 3. Multiprocessing module. Python's built-in multiprocessing module allows you to create and manage processes, each of which can run its own Python interpreter and execute code concurrently. While threads in Python are limited by the Global Interpreter Lock (GIL), processes can run in parallel and take advantage of multiple CPU cores. This module is suitable for CPU-bound tasks that can be parallelized. 4. Asyncio module. The Asyncio module provides an asynchronous programming framework based on coroutines and event loops. It allows you to write concurrent code using the async and await keywords, without explicitly creating threads or processes. Asyncio is well suited for input-output bound tasks that involve waiting for multiple input-output operations to complete, such as network communication or file input-output. 5. Third-party libraries. There are several third-party libraries available for concurrent programming in Python, such as Threadpool, Joblib, Ray, and Dask. These libraries often provide additional features or optimizations for specific use cases, such as parallel processing of data or distributed computing. The choice of threading mechanism depends on the specific requirements of your application, including the type of tasks you need to perform, the degree of parallelism required, and any performance considerations. It's essential to choose the right tool for the job to ensure efficient and reliable concurrent programming in Python. Question 5. What is monkey patching in Python? Answer. Monkey patching in Python refers to the practice of modifying or extending the behavior of modules, classes, or functions at runtime, usually by directly modifying their attributes or methods. This allows developers to change the behavior of existing code without modifying its source code. The term monkey patching comes from the idea of a monkey making changes to a program while it's running, often in an ad hoc or temporary manner. Here's a simple example to illustrate monkey patching in Python. In this example, we define a simple class myClass with a method. We then define a new function new_method that will replace the original method. By assigning new_method to myClass.method, we replace the original method with the new one. When we create an instance of myClass and call the method on it, we get the output from the patched method. Monkey patching can be useful in certain situations, such as fixing bugs or adding features to third-party libraries without modifying their source code. Testing, by replacing external dependencies with mock objects or stubs. Applying temporary fixes or workarounds without waiting for an official release. However, monkey patching can also lead to code that is hard to understand, debug, and maintain, especially if used excessively or inappropriately. It's generally considered a last resort and should be used with caution, as it can introduce unexpected behavior and make code less reliable. That's all for this video. If you found this video helpful, don't forget to subscribe, give it a thumbs up, and hit that notification bell for more content, so you don't miss any upcoming video. And, if you have any questions or topics you'd like us to cover in future videos, please let us know in the comments below. Until next time, keep exploring and keep coding. Thanks for watching, and happy coding.